Hi, my name is Mike King. I am the president of LHP Data Analytics Solutions. And today we're going to be reviewing a project that we took this summer. One of the challenges facing companies in this IoT world is connecting to their products, whether it's out in the field or in the air or on the road, and really understanding what's going on in the engine. And so Tyler's going to be walking us through a solution that provides remote connectivity analysis. We'll be predicting failure and using machine learning to really understand what's going on within the drone. The end result is really our ability to help a customer figure out what's happening in the field, and by doing that, they're able to better satisfy their customers and hopefully make more money.
Okay, now we're going to do a functional demo of the drone flying. So first we're going to start the program. Turn data 3. Oops. Typed it wrong. Alright, we're going to check that it's collecting data, and it is. So now we're going to type our command, take off. Now it's flying. Now we can see it flying. We can mess around with it. Now we can stop it manually. And there we go. It's still collecting data because it's connected through Wi-Fi. So now we can stop the program. And then we can go to our Power BI, we can refresh the data. And there we go, there's our flight. We can see when it stopped. We can see we manually stopped the drone here. You can see we were about 1 meter off the ground for, let's see how many seconds, about 15 seconds. We used about 8% battery, which is not bad. You can see the percent we were landed, flying, and default. Pitch roll yaw, we can see where we manually aborted the flight, and that's where we're detecting it. So yep, there's a little demo of our data collection there. All right, so here we're going to show, we did a little machine learning through Azure. What this does is that we take a picture of the propeller and then we can tell if it's broken or not. So what we did is that we first have to create our model, which we'll use to then predict if it's broken or not. So we first start out with our data. Visualize it. So we have our values, and then it doesn't show all of them, but it'll show this is each individual propeller, and then at the end it'll say if it's broken or not. And then we use that to train our model. And so we edit the metadata, and we split the data into a training and testing split. And here's our model, and we'll use a 2-class neural network as our algorithm. And we'll score the model and then evaluate the model. So if we look at our evaluation, you can see that we have about an 85% accuracy, and then we have a threshold of 0.5. And then our positive label is broken. It'll tell if it's broken or regular. So, and then after we do that, and we train our model and then we get it accurate about, above 80%, we'll create a predictive experiment within Azure. and then we'll create a web service that we can then call within the program through the API to test and use within a program. So we'll put in all these values, and then it'll give us if it's regular broken. So if it was all 0, it'd be regular, which is not a proper use case. To do that, we use the request response. Then we'll simply embed this code within a C# application, Python application, or a R code application. We used C# to create this program here. So we'll load in the data, and then we'll press enter. It'll make the API call, and a few seconds later, it'll tell if it's broken or not. So let's take a look at the picture, though. So here's our picture of the propeller. We'll take this, we'll change it into RGB data, which can then be summed up to a unique value that we use to train our model. So we'll take that data and load it into our program. So load, not broken. Load, no, enter. Make the API call, and a few seconds later, it'll tell you if it's a functional propeller or not. And so this is using the model that we created within Azure, and it makes the call there.
So hopefully today's demonstration gives you an example of some of the capabilities we have here at LHP. Our ability to connect to devices anywhere in the world, analyze data, provide results real time, brings a lot of value to our customers. Hopefully got to see, again, kind of the culture we bring at LHP, where we're hire really techno-functional folks that are passionate about technology, passionate about solving problems. And if this is something that interests you, please give us a call. Thank you.